Hi, welcome to week 3. So this is just a quick video just to go through M1 essentially. It's going to be very very quick because a lot of you have already started this, and there's a few people. Well, all of you should know at least some of these already. But I'm hoping that most people go for M1 because I would like you obviously to try and do well. And you've got plenty of time to do M1, so really you should all be trying to aim to do M1. That being said, I'm going to go quickly into my presentation. So what I've set up with this is essentially I'm going to be going over M1. Now, if you look at what it says further down the spec, which I've obviously put on the classroom, you'll see that it actually says you've got to compare the intrusion detection systems for M1. So if you do talk about them, you do need to compare them in terms of effectiveness and any problems with them as well. So which one's better for which situation or which company. So you could say that some intrusion detection systems are better for bigger companies or for smaller companies, or are more cost effective because some of them might be more expensive than others. So it's basically things like that. You do need to compare them at some point for M1. I'm not going to be going over spyware or virus protection because I've gone over that last year, and I've also gone over that last week as well, so I'm not going to bother covering those. In terms of alarms that's on there as well, alarms mean actual physical alarms. So when you go into a building type alarms and you trip a, a motion detector, like if you've got one in your house and it sets off the alarm, it's on about one of those type of alarms for people actually going into the building and stealing like hard drives and data. It's on about that sort of alarm. So I'm not going to go over that because everybody should know what an alarm is really. Um, Obviously, just talk about expensiveness of large buildings and stuff like that, or effectiveness for smaller buildings, or anything like that for alarms. It should be fairly straightforward. So what I'm going to be talking about in this one then is firewalls. So obviously firewalls, as we probably did a little bit of it last year, we should have done more in networking. Again, for those of you who did the networking task that I set, you'll know more than those who decided not to. But firewalls are used to essentially just detect any incoming and outgoing network traffic. So any traffic that's basically going either in and out the internet or between devices on a network, it will scan everything that's going in and out. So if there's anything that it thinks is a virus or an unwanted file or anything like that, it will detect and try to stop it. Obviously, it might not work all the time, might not be able to stop it, so it might just alert anything on the network. So it might alert the domain controller or network administrator saying something's tried getting in, or it's already got past, and we have to try and stop it. So firewalls are not you can't just use them as the be all and end all of this is going to protect my network. You can just use them for detecting things on the network instead of protecting it. So obviously, firewalls need to be kept up to date because if they're not, a new virus or a new Trojan or anything like that could come through, and it wouldn't know what it is. It would just let it through, thinking, "Oh, it looks fine." So obviously, with firewalls, they need to be kept up to date because new things are coming out on a daily basis. Things do change very, very rapidly, so firewalls do have to be updated and constantly looked at to make sure that everything's running smoothly and there's nothing strange going in and out of a network. So you can't just think, I can just rely on this for either protecting or detecting things on a network because it may not. But that's the basic gist of firewall. Obviously, some firewalls you can set up manually yourself, and sometimes within certain devices. But obviously, as most of you will know, you can buy things like McAfee or Norton, which come with firewalls. If you were doing it for a large-scale network, obviously there would be probably like Cisco firewalls or something like really large. Again, they're really expensive, so when you're talking about downsides, it could be they're expensive, it could be that they might not be able to be implemented on some systems. Um, like at our college, I'm not sure what firewall system we use, but I think it's Sophos, I think. But they might not be able to uh, be used on certain pieces of hardware. So we might have to buy newer hardware in order to run Sophos. Um, I'm not going to make any jokes about our system being slow and terrible because I'm a computing teacher and I'm not allowed to do that. But you've already heard me say stuff like that before in the past. So it might be that Sophos is compatible with older things, hence why we use it. So file/folder monitoring again. We this is in college. As most of you guys will know, there is this new folder monitoring setup thing in place where they can look at your files and think, right, what is the name of this? Is it anything we need to be concerned of? Is someone writing something like I'm going to make a bomb or something like that? Because obviously, if you put something like that, potentially it could be something serious that we need to step in and stop. So file monitoring would be used for viruses potentially, because obviously it can look at the extensions, so it could look at .exe files, for example, because they can be viruses potentially. Um, Obviously, with our folder monitoring/file monitoring, it's just for keywords. But the thing is, if you're on a network, it might be that you look for keywords. So with this, it can obviously be done for external devices, because if somebody comes and plugs an external device into a network system that's already been okayed by the network, obviously if anybody plugs anything in like an attacker into a actual device, it could be that that's got a virus on it. So if the folder/file monitoring picks it up, it can stop it. As I said before, obviously it can look for particular file extensions like .exes or anything like that. So if there's a particular file name, like a batch file or something like that, that might be virus, it might pick that up and go, oh, this could be a potential problem. Obviously, it can notify your network controller or administrator. Network controller is a server, by the way. It's not an actual person. So network controller administrator. So administrator is an actual person, whereas the controller is the server that runs the network. So it might tell that something's on there that shouldn't be. But obviously, it could bar access to them files or that drive altogether. So if you plug in a memory stick with something that's dodgy, the file monitoring system might say, do not use anything on this memory stick, bar this memory stick from the network altogether, because it can pick up what hardware it is and be like, no, stop. Obviously, with this sort of stuff, it can also see stuff like if it's been renamed when it was created, when it got plugged into the system, stuff like that. So file monitoring can be very useful, because if it picks up things that look a bit strange and say like it was renamed from something into something else. So as you can see, from here it's got name and then new name. It could be that the old name could have been something, obviously not called virus.exe, because nobody's that stupid to call it virus.exe, but it could have been something that is malicious and then changed to another name that looks fine. So it's very useful, this sort of stuff, for just detecting if anything has been picked up on your network. Honeypots is an interesting one. With this, you've got to be incredibly careful, because the whole point of it is you set up a network system to be attacked by actual attackers. So you set it up with something that looks desirable. So they don't. When I've put on there purposely advertised in quotes, it means that they will put it out onto the internet, and the internet will look at it thinking, that this could benefit me if I attack it. But obviously they've set it up so there's nothing valuable on there, and people will try and come and attack it. Obviously, the purpose of this is because it's in a controlled environment. They can basically watch what these attackers are doing, see how they attack it, and then set up a defense for when they actually deploy whatever they're setting up for real. Like, they can say they are setting up a database system and they want to test how secure it is. They would just dummy information on there that's not relevant or useful to anybody, say, oh, we've set up this new system, we're just testing it out or something like that, and people will come and attack it because obviously they think, oh, it's a new system, it might not be that secure. But obviously then they can watch how it gets attacked and then they can set up a defense. So when they set it up for real, they can stop people from attacking it. It's a brilliant idea. Obviously people do it because it works. Um, when people attack it, obviously, depending on the attackers, they might reveal themselves by mistake over the internet, which if they do, they can obviously end up being prosecuted. So it can help both the network that's trying to set up something new, and it can also help the police and stuff like that find attackers that have been trying to attack people online. So it is useful in that sense. However, because they're coming onto your system and purposely attacking it, if you've got other systems already running on there that obviously didn't mean for them to be attacked, they could be attacked in the process. So it's very dangerous because if you put a honeypot online and you've got other systems running, they could stumble into other things and obviously attack it in different ways. So you've got to be incredibly careful when doing honeypots. Honeypots are mainly used by really big companies because obviously they've got professionals running, a network and have people constantly securing stuff just to make sure that their other systems aren't compromised and stuff. But if smaller businesses did it, it could lead to really big problems. I mean, if a small business sets up a honeypot and has got nothing else there, so they literally have just set it up, then fair enough, that's a bit different because they've got nothing that they can lose. But it is quite dangerous doing honeypots, and potentially if you say we've got all this data, blah blah blah, they could try and break in physically as well. It's not just online. They could think, oh, let's go to that building because they've got all this new stuff and nick it, and see if we can get anything off it because it's brand new. So it's not just for online threats. It could be a physical threat as well. But that is pretty much it for intrusion detection systems. It's pretty easy in terms of just saying like, well, this intrusion detection system is used in this way and for this particular organization because it's going to benefit them over another organization that might use a different one for a different purpose. It's just saying like, how can network attacks be detected? That's the whole point of this merit task. So how can they be detected, and which ones are more useful in which situations? That's basically what this task is, and it shouldn't be that huge. It should be fairly easy. You could do it within a day quite easily. But as I say, if anybody's got any problems, just let me know. I'm not going to be putting up any new work until obviously the week that this is due in, so don't worry about new work going up. This is obviously M1 was already up with this, so it should be fairly straightforward. I'm going to put this out there, but for anyone who does watch the video and has not handed everything in for P1 on time, you need to come in next Monday so I can see you. Realistically, if you're not handing in work like we said before, you need to come in and see us, or at least tell us, because some people have told us, and that's fine, and we've put things in place, but some people are just, I think, getting scared, not telling us, and then not handing anything in, and that doesn't help us at all. Like, we want to help you as much as we possibly can, so please, 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 if you're struggling with stuff, and you're finding it difficult to get things in on time, let us know first. Don't just leave it. Don't just be like, I'm not going to do it, and I'll just, I'll just sit in a corner and not contact them at all, because that'll make everything go away, because it won't. And also, if anybody's thinking of leaving the course, and this is directed at someone in particular, you need to let us know if you don't want to carry on. If you don't want to carry on, come in and see us. Otherwise, it could lead to potential legal action, depending on if you don't come in. So yeah, so that's it for this week. If you've got any trouble, let me know, as I say, and I'll see most of you on Monday, hopefully, anyway. Bye.